Hello all. So let us work out some numerical questions. From my side, I will make sure that every numeric question ever asked will be explained to you. From your side, what you have to do is three things. One, maintain a notebook for these numeric questions itself. A large size notebook where you have written detailed out every simple thing which has been explained to you. See, I have few notebooks which I have been still maintaining it from my UG. Also, second point, have a 80 pages notebook. Wherever I tell you that you have to memorize this, then just write it down in that separate notebook. Third point, whatever being taught, please attend the test in the website. With you doing these three things, I can assure that you will attend these questions with utter confidence in the examination. So let's start with the questions. So your next question, the planning norms for provision of schools in a given town is shown in the table. So there are three types of schools, which is elementary, primary and secondary school. So the elementary school is for 1 per 2500 persons and it has a land area. The land area for that one particular school will be 0.4 hectares. Similarly, they have given for primary school and secondary school. So what are they asking? Total land area required for providing all types of schools for a population of 2 lakh people is dash hectares. Okay. So let us first write what they have given. So now they have given types of schools, which is elementary, primary, secondary, and they have given the population norm. So that means in the total population is 2 lakh people. Okay, they have given that also. Population is equal to 2 lakhs. Okay, so the total population is 2 lakh. In that 2 lakh, for every 2500 persons, one elementary school should be there, which means 2 lakh divided by 2500. Similarly, for every 5000 people, one primary school. So 2 lakh divided by 5000. So for every 12,500 people, one secondary school. So dividing this will give you how many schools are required. Number of schools required. Okay, so that is, if we divide this, we'll get an answer which is 80, 40 and 16. So also they have given land area for each school. One school should be of how much hectares. That also they have given a standard. So now our duty is, we know how many schools is required. Now we know for one school how much land area is required. Multiplying this will give us the total land area required for each type of school. So we are going to multiply this with 0.4 and this primary school with 1.0 and your secondary school with 2.4 hectares. So that will be giving you an answer which is 32, 40 and 32. Okay. So we have the land areas, total land areas for the different schools for each category. So what is the overall land area? Calculating the overall total schools, how much land area is it going to take? So that is, adding all of these, we will be getting 104 hectares. Okay, so this is the answer. So your next question, for an activity, optimistic time duration is 4 days. Okay, which we call it as TO. Pessimistic time duration is 11 days, which is TP. And most likely time duration is 8 days. Okay, so the Perth value of time duration is dash days. And we have a formula for this. So The part value of time duration is equal to TO plus 4Tm plus TP divided by 6. So you will have to memorize this formula as well. So substituting which we will be getting 4 into 4 into, what is your Tm over here? 8, and TP is 11 divided by 6. So which you will be getting 7.83 days. Okay. Always write with given first, which is TU is equal to 4, TP is equal to 11, TM is equal to 8. Okay, we are asking for. Okay. Your next question. The water consumption of a high-rise apartment building with 60 dwelling units, 60 flats we can consider, having an average household size of 5 persons is 135 LPCD. I'll tell you that. So, assuming 80% of the total use is met, 80% is consumed, okay, with recycled water supply. The daily domestic demand for the building is how many liters? So, let us break it down first. Given how many dwelling units? 60 dwelling units are there. Average household size is equal to 5 persons. Therefore, population will be 300. 60 into 5. Okay. Okay. And water consumption is how much? Water consumption is equal to 135 LPCD, which is liters per capita per day. So 1% is consuming 135 liters per day. Now how many persons are there? 300 persons. Okay. Before that, what are they asking? Next is assuming 80% is already used. Equal to 80%. So demand is how much? Is the question. Now we'll go for solution. See, we already know that demand is, if 80% is consumed, then the balance is the demand, right? 20%. Okay. Now let us first see how much water has been consumed, or okay, how much water will have to be consumed. That let us first find out. So that is, per person consumes 135 liters per day. But how many people are there? 300 people. So total water consumption is equal to 300 into 135. So that gives you 40,500 liters. Out of this, 80% is already consumed. So the balance 20% is the demand. Okay. Now demand of 20% is equal to 0.02 into, now you can put the percentage calculation also, like 20 divided by 100 into 40,500. Okay, 20%, you can do that way also. 40,500 equal to, final answer is 8,100 liters. This is your answer. Meeting your next question. The indoor illumination requirement for a building is 350 lux. If the daylight factor is 2.7 and design sky illuminance is 9000 lux, then the required supplementary artificial lighting in the building is how much lux? Okay. First, we'll try to understand the question. See, they are saying there's a building which has illumination requirement. The lighting illumination requirement should be of 350 lux. Okay. The daylight factor is 2.7. So what is daylight factor over here? Daylight factor means nothing but it is the ratio of the outdoor comparing the outdoor illumination and the indoor illumination. So outdoor how many lux is there and indoor how much is there. A comparison of that, a ratio of that is called daylight factor. This is a simple term I'm telling you. You can just go and read the technical definitions as well. Okay, this is for your understanding. Secondly, they are saying that the outdoor illumination, the design sky illumination is 9000 lux. So outdoor illumination they have told you. Indoor how much is there they did not tell you, but they told you how much is required. 350 lux should be there, and their question is how much artificial lighting is required. Means for that you have to first find out how much is already present there. Then only you will know if the requirement is met or not. If the requirement is not met, then we have to subtract it from the given requirement, and we have to tell this much lux is to be artificially produced. Okay, while we calculate it you will be understanding. So the given is required illumination, which will be 350 lux. The daylight factor is equal to 2.7. Outdoor illuminance is equal to 9000 lux. Supplementary illuminance is how much required is the question. For that we have a formula. There are different formulas for this, but considering the values which have been given over here, so we have daylight factor, outdoor illuminance, and we are also going to find the indoor illumination. So considering these values, there is a formula which is daylight factor is equal to indoor illumination by the outdoor illuminance into 100. So we know daylight factor over here. We don't know this, but we know this. Okay, so we are going to substitute them. 2.7. Oh. Okay, so the answer is 243 lux. So the illumination already available, already present indoor is 243 only. But the standards is saying that 350 lux is required. So how much artificial is required? Therefore, shell lighting requirement is 350 minus 243, which gives you the final answer as 107 lux. Please memorize this formula. When existing indoor illumination and existing outdoor illumination are given only, you will be going for this formula. And there are certain other different types of questions where you will be finding a different type of daylight factor formula. For this particular question, memorize this.